Hi, today I'll be going over some questions from the first presentation on the response adaptive randomization design. The first question, what code was used to perform this simulation and what basic information was required to run this code? The Shine design was simulated including the group sequential stopping boundaries, the sample size re-estimation, and the chi-square test between treatment groups as the primary analysis. 10,000 trials were simulated for each scenario. All simulations assume no lost follow-up and an accrual rate of 33 patients per month. Thus, at each interim analysis, there are approximately 100 patients enrolled, but without complete follow-up through 90 days. The code was not made available in the paper, but the information above should help with this question. Second question, the response adaptive design is related to the quality and representability of the first stage subjects to the whole subjects. The possibility of a larger sample size required in the second stage exists. In fact, some raw results are worse or less significant than those of the standard design. How to avoid this issue in the response adaptive randomization design. So this issue is not really easily avoided, and that's one of the main reasons that response adaptive randomization is not implemented widely. It is rare for the results to be more efficient than a standard study design, which is why implementing RAR is not always the best option. The ethics and efficiency loss should be weighed in order to determine if the RAR design is optimal. Third question. The RAR method will result in different randomization than a classically randomized trial. In a classically randomized trial, the treatment sequence of each subject is already predefined before the trial starts. Therefore, even with dropouts of some patients, the study will proceed as planned. However, the allocation for RAR evolves within the ongoing trial. How does RAR adjust for dropouts in favor of one treatment or other protocol deviations without introducing operational bias? Basically, for the RAR method, it comes down to the way that the algorithm was designed for handling this and how often it'll be run. Not all RAR designs will treat dropouts in the same way, so future allocation of patients is kind of based on that part of the algorithm. Or protocol deviation depends on how that design treats those patients. Next question. The Shine design includes sample size re-estimation in the covariate adjusted final analysis. At what stage and how is the covariate balancing with assignment of different control limits for the p-values performed? It is only during the interim analysis or at final analysis. Covariate balancing can be performed at any stage of the trial. For the Shine trial, the simulation did not include covariates in the results of the simulation study. Next question. How was the Goldilocks design retrospectively executed upon completion of Shine? Also, what was the ultimate decision to not implement the Goldilocks design due to a loss of power? The paper does not detail how the Goldilocks design was retrospectively executed after the completion of the Shine trial, and the loss of power was a big reason that the design was not implemented. Another difference, which was most likely a reason for this, was that the designs had two different hypotheses. The Shine design used a two-sided alternative hypothesis, while the Goldilocks design used a one-sided alternative. The next question. My question is whether there would have been another RAR model or method with similar benefits other than the Shine design that you would have suggested be used in place of the Goldilocks design. Another RAR method that could have been used in comparison to the Shine trial would be a RAR design with covariate adjustment in the final analysis in order to compare the effects between the different methods of the response adaptive randomization design. Next question. What was the time taken to arrive at the primary response outcome for the Shine and Goldilocks design features? The Goldilocks design was not implemented in this trial, so I'm not sure how much time it would take to get to that endpoint. Recruitment rate is a large factor in how long it takes to arrive at the primary response endpoint, so the design with the smaller sample size would generally achieve the primary endpoint faster. For the simulated studies, the sample size for the Goldilocks trial was 979 compared to 1,114 for the SHINE design. And that's it. Thanks for listening.